Okay, let's start with the number. $235.
Mm-hmm.
And just to be clear, that's not for a graphics card or, some fancy new solid-state drive. It's a cable.
A single 15-meter cable, to be specific.
Right. We're doing a deep dive on let me get this right, the NTI DP8K-FOCMP-15M-MM. And I think the mission today is pretty simple. Why does a cable cost this much?
It's a fair question. I mean, we're all used to grabbing a $10 cord from a bin at a store.
Exactly.
But when you actually dig into the technical sheets on this thing, you realize it's not really a cable in the way we think of one. It's more like a piece of active infrastructure. It's designed to solve a physics problem.
And that problem is distance, I'm guessing.
It's distance and just the sheer density of the data. We're trying to move 8K resolution video, that's 33 million pixels, refreshing 60 times a second.
Or 4K at 120 hertz.
Right. And all that data, we're talking about a bandwidth of 32.4 gigabits per second. If you try to push that through a normal copper wire for 15 meters, or about 50 feet,
it just dies. Physics takes over. You get signal loss, flickering.
Exactly. It's called attenuation. The signal just degrades. And that's where the hybrid part of this NTI cable comes into play. It's an active optical cable.
So it's not just copper wire inside that jacket.
No, not at all. It's a hybrid. It does have copper cores for let's call it the low bandwidth stuff, like power delivery and the digital handshake between the source and the display.
Okay.
But for the heavy lifting, for the actual video data itself, it uses multimode fiber optic cores.
So you're swapping electrons for pulses of light.
You are, which means you get basically zero signal loss. The picture quality you get at 15 meters or even 100 meters on their longer models is identical to what you get at 1 meter.
One detail in the specs really stood out to me. Usually when you see active cable, it means you need an external power source.
Mm-hmm.
You've got to plug it into a USB port or a wall adapter to boost the signal.
Mm-hmm.
This one doesn't need that.
And that is a huge selling point. It's completely plug and play. It's engineered to draw the tiny bit of power it needs for the optical converters directly from the DisplayPort interface itself. No extra power bricks, no little USB pigtails hanging off it.
That's pretty slick. And that brings us to where you'd actually use this. The name has CMP-rated Plenum in it. That sounds like a very specific, regulated term.
It is, and it's critical. In commercial architecture, the plenum is that open space above a drop ceiling or under a raised floor. It's where the air circulates for the building's HVAC system.
Ah, so if there's a fire, that's exactly where smoke is going to spread first.
Precisely. And a standard plastic cable jacket, it'll burn fast and release all these really toxic fumes. A CMP rating means this cable's jacket is made of a special fire-retardant, low-smoke PVC. So if you're installing 8K digital signs in an airport or a hospital,
you're required by law to use something like this.
Often, yes. And the hospital example is interesting for another reason, too, that's in the specs.
Right.
Interference.
EMI and RFI.
Yeah, electromagnetic interference. Copper wire is basically a long antenna. It picks up all the electronic noise from things like MRI machines, big fluorescent light banks, airplane electronics.
But fiber uses light.
And light is completely immune to magnetic fields. So if you're in an environment where you need a perfectly clean signal, like a medical imaging suite or a TV broadcast station, you pretty much have to go with an optical solution.
Now, despite all this incredible tech, there's a little reality check buried in the documentation. We're talking about this cable being 8K ready, but there's a specific note about the Dell UltraSharp UP3218K monitor.
Oh, I love this detail. It really puts the challenge of 8K into perspective.
It says that to run that specific monitor at its full 8K 60 Hz resolution, a single cable isn't enough.
Nope.
You have to run 2 of these cables in parallel to get the bandwidth you need.
It just shows you the insane data requirements we're dealing with. Even with a cutting-edge 32 gigabit fiber optic solution, uncompressed 8K is so massive that some hardware still needs what is essentially a dual-lane highway to handle it all.
Wow. It handles the audio just fine, though, right? It says 32 uncompressed channels.
Oh, absolutely. For a high-end home theater or a complex video wall, it's a beast. It handles dynamic HDR, deep color, everything. The video is just the hungriest part.
So to wrap this up, we have a $235 cable that uses glass and light to defy the laws of copper. It's safe enough to install inside an airplane, and it powers itself.
It's the hidden plumbing, really, the invisible high-tech stuff that makes all the shiny 8K screens we see actually possible.
It definitely makes you look at the wires behind your setup a little differently. But it also leaves us with a kind of a provocative thought to chew on. If getting 8K to work reliably over any real distance already requires glass fiber and, in some cases, too expensive cables, are the copper wires inside our walls already obsolete for high-end media?
That is the question, isn't it?
Thanks for listening to The Deep Dive. We'll catch you next time.